Hello students, let's learn some new things. In chapter number 14, symmetry. Line symmetry and rotational symmetry. We have already learned about line symmetry and rotational symmetry. Now we will discuss the shape which have line symmetry and also a rotational symmetry. So for that we will take square. As we already have discussed, a line of symmetry for a square, it is 4, and order of rotational symmetry, that also we have discussed in our earlier video lecture, it is 4. Here we can see that these are the lines of symmetry. That means one vertical line, one horizontal line, and two diagonal lines. That is 1, 2, 3 and 4. These four dotted lines are the lines of symmetry for a square. And when we take this point P and we rotate in a clockwise direction, or we can rotate anti-clockwise also, we can rotate clockwise direction in a such a way that this point P comes here, we get rotational symmetry. Again P comes here. When we rotate, rotational symmetry, again rotational symmetry, and again exactly same. So here we are rotating 4 times, we are getting same exactly copy as a original shape. That's why the order of rotational symmetry for square, it is 4. Next we will see a circle. Already we have learned that line of symmetry for a circle, it is infinitely many. Infinitely many are the lines of symmetry in a circle. Now what is the order of rotational symmetry for a circle? For an example, in a circle, how many points are there? Infinitely many. If I take point P and this is center of rotation. This is center of rotation. Now we have to rotate this circle. Now if I take this point and this point P, we will rotate in such a way that this point P comes here. We will get same exactly shape circle. If we rotate in such a way, this way, we will get same shape. Again this way, we will get same shape. That means if from the center of the rotation, if I move the circle, I will get exactly same shape which was at the first place. That means original shape. Again if I am moving in this direction, in clockwise direction, in such a way, again I am getting the same shape. If I move this shape, again I am getting same shape. That means in a circle, for any angle, if you move a circle with the center of the rotation, that is center of the circle, if you move the circle at every angle, you will get a rotational symmetry. So the order of rotational symmetry for the circle, it is infinitely many, because as we have learned, between any two number there are infinitely many rational numbers, and therefore order of rotational symmetry for the circle, it is infinite, and line of symmetry for the circle, it is infinitely many, infinite. Let's solve exercise 14.3. Question number 1. Name any two figures that have both line symmetry and rotational symmetry. As we have discussed earlier, we have discussed two shapes, square and circle, which have line symmetry also and a rotational symmetry. Square and circle. And also we can write other shapes also, as we have discussed that the triangle, equilateral triangle has lines of symmetry 3 and rotational symmetry 3. So here also we can write equilateral triangle. Here we have to write only 2, but we can write as many as we can, as we know. And also we have learned about regular pentagon Regular pentagon has a line of symmetry 5, and order of rotational symmetry is also 5. Next, question number 2. Draw, wherever possible, a rough sketch of number 1. A triangle with both line and rotational symmetries of order more than 1. So which triangle has line symmetry and also a rotational symmetry of order more than 1? It is nothing but equilateral triangle. Equilateral triangle which has a line of symmetry of 3 line of symmetry and order of rotational symmetry is also 3. Next, number 2. A triangle with only line symmetry and no rotational symmetry of order more than 1. So for that, it is nothing but isosceles triangle. Here, in isosceles triangle, there is a line of symmetry, one line of symmetry, and rotational symmetry. So here, if we take this point P, now we have to move this shape in such a way that this point comes in this other point. When this P comes in this point, the shape of the triangle is not exactly same as the original shape. Again, we will move here. Again, we get a shape of the triangle which is not exactly same as the original shape of a triangle. And again, we will move it here. Again, at the original place, this point P comes, and that original place after 360 rotation, we get the exactly same copy. That's why we can say that this isosceles triangle has a rotational symmetry of order 1, not more than 1. So therefore, a triangle with only line symmetry and no rotational symmetry of order more than 1 is isosceles triangle. Number 3. A quadrilateral with rotational symmetry of order more than 1 but not a line symmetry. So we have to find a quadrilateral which have a line of a rotational symmetry of order more than 1 but no line of symmetry. So in a quadrilateral, we have got two quadrilateral which have zero line of symmetry. One is a simple quadrilateral and another one is parallelogram. So if we take a parallelogram, so in a parallelogram, we get order of rotational symmetry which is more than 1, which is 2. Here, this is a parallelogram. We can take one point A. When we rotate this parallelogram at 180 degree angle in a clockwise direction, we get this shape. A comes here and these two shapes exactly look same. Again, we will rotate this parallelogram. These two are angle of center of rotation. So from this center of rotation, we have to rotate the parallelogram for 180 degree. We get exactly the original shape. So here, rotation, order of rotational symmetry, it is 2, 1 and 2, 180, 2 times 180, 180. So order of rotational symmetry it is 2, and the line of symmetry, as we already have discussed, it is 0. So question was a quadrilateral with rotational symmetry of order more than 1 but not a line symmetry. So answer is parallelogram. And last sum of question number 2. 4. A quadrilateral with line symmetry but not a rotational symmetry of order more than 1. Which now we have to find a quadrilateral. It has a line symmetry but not a rotational symmetry of order more than 1. And this is nothing but a kite. Kite is a quadrilateral. It has a one rotational symmetry, that is this line, and order of rotation it is only 1. As if we move this kite in an anti-clockwise direction, if we take this point as a point P, if we move in such a way that this P comes here and we see the shape after rotation, that is this is a center of rotation, and from that point we have to rotate this kite shape. This P comes here, and after rotating we can see that the shape which we are getting after a rotation, it is not exactly looks the same. Again, same way we have to rotate again, same again. After 360 rotation, that means full rotation, we get the same copy of the kite. and that time only we get same copy, not in another other angles. So that's why the order of rotational symmetry for a kite, it is 1, and line of symmetry, it is 1. So the question was a quadrilateral with line of symmetry but not a rotational symmetry of order more than 1. So answer is kite.